Hello everyone. Today we're looking at our fourth method in solving for T1 and T2, and we're using the concept of algebra. Now the first thing we're going to do, as we normally do, is to convert our diagram into a free body diagram. From our free body diagram, we're going to find the x and y components of T1 and T2. Starting with T1, the x component is given as negative T1 cos 40 degrees. Again, it is negative because it's going towards the left or in the negative x direction. The x component for T2 is given as T2 cos 30 degrees. It is positive, going towards the right or in the positive x direction. The y component for T1 is given as T1 sine 40 degrees, while the y component of T2 is given as T2 sine 30 degrees. Now from this, we can find the sum of the x and also the y components. And so let's start with the sum of the x component first. Again, just to point this out, is that if you notice that the sum of both x and y equals to 0, simply because the body is in equilibrium. Now again, jumping over to the sum of the x component, which is given as negative T1 cos 40 degrees plus T2 cos 30 degrees, again equal to 0. From this equation, we have here T1 cos 40 degrees equals to T2 cos 30 degrees. So from this, we can find our T1. And so T1 will be given as T2 multiplied by cos 30 divided by cos 40. For T2, it is given as T1 multiplied by cos 40 degrees divided by cos 30 degrees. Now let's find our sum of our y component, and it is given as T1 sine 40 degrees plus T2 sine 30 degrees minus 490, and it's all equal to 0. Why we minus 490? Because 490 is going downwards, while the y components of T1 and T2, they are going upwards. All right, so they are opposing, in other words. All right, so therefore from this, we can also state that T1 sine 40 degrees plus T2 sine 30 degrees equal to 490. All right, this is really amazing, and also algebra is awesome. All right, so what we're going to do here next is something that is very important. We're going to solve for one thing. All right, so what we can do is really to substitute T2 into this equation. All right, and so let's do that real quickly. And so by substituting in this equation, what we have here now is that we have T1 sine 40 degrees plus T1 multiplied by cos 40 degrees divided by cos 30 degrees multiplied by sine 30 degrees equal to 490. All right. And so from this now, what we're going to do is to work out the sine of 40 and also the parentheses as well. And so what we have here as a result, we have 0.643 T1 plus 0.442 T1 equals to 490. All right, so by working out that, that's what we get. And so from this, we can add the T1s together. And so therefore we have 1.085 T1 equals to 490. So therefore T1 equals to 490 divided by 1.085. Therefore it equals to 451.61 newtons. All right, so this is amazing. All right, and so what we're going to do here now is to solve for T2. All right, and so we can put T1 in this equation, all right, because T2 is equal to T1 multiplied by cos 40 divided by cos 30. So we can simply put T1 in this equation, and such we have this expression. Now from this, T2 now is given as 399.47 newtons. All right, and so this is our final method here in solving for T1 and T2. And I want to thank you for watching this lesson, and I want to remind you that you need to remember that sometimes not getting what you want is a wonderful stroke of luck, because not everything that you really want is really for you. All right, it could be to your own detriment. Anyhow, I want to have a great and blessed day, and I will talk to you soon.